Let's take a look at the OSD Core Driver. So we go to Vitus in here. This is again within the VGA core the header file and the implementation, so we get to see both of them. Okay, so taking a look at that, we have the bypass register address, the foreground color register address, and the background color register address. And here a few interesting things. So the chroma key, we're defining it as 0, like the rest of them, and the null character. So the null character is actually when you want to get one of the tiles to be transparent, you just assign it the null character, and the null character will basically just display a transparent color, which is 0. It will put chroma key color, which is 0, inside that particular tile, or inside a particular tile you write into it. And then here we're figuring out the maximum number of tiles in our resolution, which is basically 80 by 30 for the VGA. That's like we saw in the construction of the OSD core. Then the methods we have a constructor, and if we take a look at the implementation, what the constructor does, it actually just stores the base address and sets the color. It basically sets the foreground and background color. That's what it does. And what we're doing in here is we're setting the foreground color to be basically full RG. That's the F is the G, so it's fully green, the maximum green you can get. And the background is actually the chroma key, so it's basically green on transparent. So whatever background you have on top of it, you write, it's just going to be the green color. That's how the so of course, where do we get that set color? Well, it's actually one of the other functions, one of the other methods that the driver actually provides. Again, as the name implies, it sets the colors for the foreground and the background. So let's take a look at the implementation. The implementation, it just goes and write the foreground color, which is here in that particular register, and the background color in that particular register. That's how straight it is. Next, the function that we have in here, which is write character. So you're telling it, well, in location X, comma Y, please write this particular character, and whether you want it highlighted or not, by default it is not highlighted. So let's see how that is actually implemented. So the way we implement it, again, based on the register map, we have to concatenate the X and the Y. That's basically the XT and YT, but we just call it X and Y in here because the user doesn't know that there's an X and a Y and an XT and a YT. It just knows that in a certain location in the tile, I just need to specify the X and the Y. So we're just doing that concatenation in here. Okay, and then we're asking whether it is reversed or not. If it is reversed, basically we pass that particular value to 1. We're just basically attaching a 1 at the most significant bit. Here, basically at the very last bit, we're just setting it to 1. Other than that, we just keep it as is, and now we have that character. All we have to do is just go and write it in that particular location. So what is the character offset? Well, that's what we computed in here, and the data is actually what we have. And we'll just go to the upper half of the register map and just in a specific location and just write that value, and then it will be read by the core, it will be sent, and you will see it on the display in that exact X on Y. Okay, so then we have another function that basically clears the screen, as the name implies. It just basically makes everything transparent. So it goes through all the X's to, this is why we have the char X max and Y max. Like how many tiles do we have? 80 by 30. We just go by them tile by tile, and we write a character at that particular exact location, and that character is a null character, which is basically just, in here we're setting it up to be the chroma key. If you set it up to be the chroma key, you're basically making the whole output for that particular layer as transparent. If you set it up a little bit differently, you can basically make it maybe black by just setting it to a little bit higher than 0, maybe by 1, and that should basically just make it a black screen completely. It will cover the background at that point. And then in here, what we have the bypass. It's implemented exactly like the other cores, and in the private members, we only save the base address.